Okay, let's look at some application problems now. We have finding the equation of a tangent line. Yes, you know it. It's important. It's most definitely on the test. We've seen it in almost every single section that we found derivatives. I can't express the importance of this. So you've got to know how to find the equation of the tangent line. Again, the first thing that we need is the point. Anytime you want to find the equation of the line, you need the point. Well, reading through the problem, it says find the equation of the tangent line to the graph of f of x equals 4 times the natural log of x at the point 1, 0. So it gives us that point is 1, 0. The second thing we need is the slope. And to find the slope of a tangent line, you're going to find the derivative of the graph at that given x value. So in this case, it's at x equals 1. So let's look at finding the slope of the graph. If the function is 4 times the natural log of x, derivative is not hard to find at all. That would be 4 times, well, the derivative of the natural log of x is 1 over x. So I'm getting a derivative of 4 over x. But we care about at x equals 1. So that means it would be 4 over 1, which is just 4. So that's our slope. So we now have a point. We now have our slope. Now we can do step 3, which is put it into point slope form. So that's the y minus y1 equals m times x minus x1. Well, in this case, we would have y minus, well, our y value is 0, nice, equals m, which would be a 4 times x minus our x value, which was a 1. Y minus 0 is simply y. Let's distribute that 4 through. So we have 4 times x and 4 times negative 1. 4 times x is 4x, and 4 times negative 1 would be our minus 4. So what did we just get? We got the equation of the tangent line being y equals 4x minus 4. Again, always a good idea. Verify your answer. Remember what the heck we're doing. So what we could do is go on to Desmos. We could graph y equals 4 natural log of x. We could graph the tangent line, y equals 4x minus 4. What we should be looking at is the picture of a graph where these two graphs, these two functions, meet at the point 1, 0, and the slope of the tangent line, y equals 4x minus 4, should look like the slope of the graph at that point on the function y equals 4 natural log of x. Let's do some more applications. How about finding the rate of change? It says a group of 200 college students was tested every 6 months over a 4-year period. The group was composed of students who took Spanish during the fall semester of their freshman year and did not take subsequent Spanish courses. So you took Spanish 101 and then you didn't go from there on out, essentially. It says the average test score, P, which is a percent value here, is modeled by P equals 91.6 minus 15.6 natural log of T plus 1 for 0 less than or equal to T less than or equal to 48, where T is the time in months. So 48 months, we're talking about 2 years. So they did testing throughout 2 years. It says at what rate was the average score changing after 1 year? So we want to know a rate of change at a specific period of time. Anytime you want to know a rate of change at one given point, you are finding a derivative. So you got to remember that. Rate of change, one at a single point, derivative. So what are we going to do? We are going to find dp dt when t equals, well, it's after 1 year, and t is measured in months, so we got to be careful here. 1 year is 12 months. I think earlier I said that this 48 months was 2 years. I don't know why the heck I said that. This is good for 4 years. 48 months is 4 years. So 1 year is 12 months, so we need to plug in t equals 12. Let's remember our units here. P here is percent. T here is time in months. So what should be happening to their test scores? Well, if you notice, as you go from left to right on this graph, you can see that your test scores decrease. And a lot of you probably realize this with any foreign language you took in high school or thus far in college, is when you're taking it, yeah, you know it, but very quickly you lose it. Same thing with mathematics here. If you use it, great, you'll remember it, but if you don't use it, you'll lose it. Okay? So it shows that there's a steep drop at the beginning and then it gradually goes over time, and you're not passing the test. 50%, right, is probably your F level. Well, 60% is really your D, so that's passing. You're not passing the test, but you don't go down to 0. You don't forget completely everything, okay? So let's go ahead and do this. We want to find P prime, the derivative of P. So what's P prime? Well, it's the derivative of P. What's the derivative of 91.6? That's 0. And then what's the derivative of negative 15.6, the natural log of T plus 1? Well, it's negative 15.6, your constant multiple, times the derivative of natural log of T plus 1. Well, that's 1 over what's on the inside, so that's 1 over T plus 1, times the derivative of the inside. The derivative of the inside, well, let's just write that. Here's T plus 1, and then we'll do the prime on that one. Okay? So what is the derivative of T plus 1? That's quite simply 1, isn't it? So it seems to me like my derivative of P, the percentage, would be negative 15.6 divided by T plus 1. Quite simple there, but we want to do that at the given time frame, and this was at 1 year, but remember we have to plug in months here. So at t equals 12, what would we have? We would have negative 15.6 divided by 12 plus 1. Please put that into your calculator. Let me know what you're getting. I'm getting a value of negative 1.2. I'm glad that it's negative because remember the negative helps us. And then we got to think about the rate here. So what does this mean? Well, this means the student's scores were decreasing by 1.2% from, and this is per month, right? From month 12 to 13. So again, this does not tell you what the score was. It just tells you what your score was changing by. So if you look over here, let's look. When it was 12, it looks like the score was roughly about 50%. I know it's not exactly. I'm just trying to give you a big idea here. Okay, so the score was roughly 50%. Each student was scoring on average about 50%. So what would happen between 12 months and 13 months? Well, it's supposed to go down about 1.2%. So if at 12 months they were getting 50%, at 13 months if I retested them, I would expect them to get about a 48.8%, 1.2% less than whatever it was. So again, this number does not give you the score, it gives you the change in score, the rate of change in score. I hope that helps.